Harddisken, which maybe you can explain what that is.
Yeah, okay.
There's a few people here outside of Denmark as well.
I'm not quite sure what this works. Can you hear what I'm saying? Okay. Well, Harddisken is basically it's a radio program, and we've been running for 22 years. It's about technology and the impact that technology has on society, people, politics, economy, and so on. So it's not really a gadget program. And it's on the Danish Broadcast Corporation, Channel 1 on the radio, which for those of you who don't know, Denmark's radio, as it's called, it's a public service station like the BBC, or if you're from the States, it's a bit like NPR. So it's in-depth talk radio, 1 hour every week, and we've been running since '94. I guess that's it for the introduction. Vanessa asked me to talk about how we think about technology and how we sort of choose our stories and the way we tell them. So I will start off with that, and then I will sort of move into another landscape and end up talking about another project that I'm involved in, which is also about creativity and getting new ideas, developing products, and so on. Actually, I was thinking while I was biking here this morning, strange things occur in your mind when you're biking or having a shower. I mean, that's the best way to get new ideas. And I was thinking, wow, this summer is 30 years ago that I started out as a journalist, and I started to think about what kind of products and what kind of tools that I had then. And I realized that I had to go to an office every day and sit beside a phone. And I had to wait for everyone I called. I mean, usually they want to talk to a reporter, so you have to wait for them to call back. So just sitting there every day with a typewriter and a phone at this desk waiting for people to call me. The funny thing is, if you speak forward 15 years, I was still doing the same thing. I was still sitting at an office waiting for important people to call me back, and they never called me back. I had to call them again. I was sort of stuck at this desk for like 8, 10, maybe 15 hours a day. And today I can come here with my smartphone, my sort of pocket supercomputer, and I got it all there. I don't really need an office. I can record everything there. I can show you my slides. And it's actually a development that you don't really consider every day because you sort of take it for granted. First story. This is a person in a group. It's a picture that I came across in the Boston Globe in 2009. This guy is called James Tracy. He's the headmaster at a high school in the north of Massachusetts in the United States. And he's standing in a room which used to be his library at the school. He's looking a bit confused. So what is missing from this picture? It's a library. Yeah. What do you mean? I mean, you can see some books down there, but yeah, someone said it. No books. So what is actually happening? There's something funny happening with my slides actually. I can't see the. What is that? It's not a Windows phone. Because it's not a Windows phone.
Maybe you have to silver phone? I think you have to silver phone. It's silver phone.
It usually works. Something like here. Oh, okay. We'll just, well, what you can't see at the bottom here is a Kindle reader. So what he's actually doing, he's throwing out the books. He's actually giving them away. He's not burning them. He's throwing out the books, or he's giving them to some of the more specialized classes. So if you have an art class or a class of design, the books will be in the classroom. So he's not really throwing out all the books. But what he's doing is he's giving all the pupils a Kindle to read on, and he's giving them access to databases. This was before the iPad and the iPhone 2009. I don't know if you remember this times. But anyway, he's saying that he's actually giving oxygen to the learning environment because all the librarians, they will actually be present in classroom instead, and sort of the knowledge in the books that will sort of penetrate the whole school, and they don't have to go to the library anymore unless they want to search for something in the database. Because the books, they were actually just standing on the shelf collecting dust because the pupils didn't really want to read them anymore because they were outdated and so on. I started talking to this guy because he sort of seemed like an old school guy, but he was really into the future because he had this collaboration with something called Singularity University. You can't see the logo, you see the logo later. Yeah. Anyway, we have to live with it. Down here, there's a logo of Singularity University. Singularity University was at that point something very new in Silicon Valley. It's sort of a startup university called Startup Education. And it's founded by several people, but among them is this guy called Ray Kurzweil, who was at that time living in Massachusetts, not far from this school called Cushing Academy, where James Tracy was the headmaster. And James was really inspired by the ideas of Ray Kurzweil and the Singularity University. Because what Ray Kurzweil claims is that the way that technology develops has a very crucial impact on us as people and on the pupils at this school, because they will spend 4 years there, but the world will develop at a very, very fast rate during those 4 years. I mean, remember Airbnb, Uber? For how long have they been around? I mean, they have been around for like 4 or 5 years. So the world and the companies that we create, the products we create, they develop at a very, very fast pace, while people are still in school being taught by books that are outdated. So that was the kind of thing that James Tracy wanted to implement at this school. So technology, products, the thinking about them, the ideas that we sort of create, the platforms we create with our technology, is very crucial to the way we educate people, but it's also very crucial to how the rest of the society works. We also look at it like this. This is the exponential growth of computing. According to Ray Kurzweil, in around 2020, we will have a computer which has the same computing power as one single human brain. But in 2045, we will have a computer which has the computing power of all human brains together, which of course leads into what he calls the law of accelerating returns, which means that this will have an effect on society, that we will have these very, very fast supercomputers. He's also talking about what will happen to us and to our society when we have this very, very accelerating development in technology. And he's talking about something he calls the singularity, which is a point in time and space where you can't really understand the event horizon, which means that you will have stuff, computers, inventions, that you can't really see where will lead us. And we have had these occurrences many times in history. I mean, when we developed the printing, we found out how to print, we learned to read, we discovered fire, we made the computer, the Industrial Revolution, 6 days and so on. There are all sorts of singularities, but they come closer and closer, which means that we'll have this speed in development. If you look at products, you see sort of the same circle. You see more and more products, more and more ideas, more and more platforms that you can work on or work with, and they will have an impact on your life. I mean, you're going to talk about some of the data halo and how technology in that manner will impact us. And of course, some people will panic when they think about this because the speed will increase. But if you look at it in tech terms, so to speak, it's mostly about Moore's law, which means that the computing power of a chip will double every second year. And actually, this has come true for like 50 years, because this Sunday was the 50th birthday of Moore's law. And they actually expect it to continue at least 10 years more with the current technology. And then they will sort of have a paradigm shift. They believe the people who are working with this, like people that have Intel, which is a company that Gordon Moore founded back in '68. So you will have more computing power every year, and it will be at the same price, meaning that it will actually be cheaper. Another thing to remember is that these technologies will be connected in a network, and the network effect, which Metcalfe described some years ago, says that the value of network is increasing exponentially. So, I mean, the more people you will have on Wikipedia, the more value Wikipedia will have for you. Same thing goes for Facebook. This is the Facebook server park in Rudolph in Sweden. And of course, Facebook has had this tremendous growth because of the network effect also. When it comes to products, what you can't read here at the bottom of the screen is it says that in 2020, 8% of all grown-up people on the planet will have a consumer computer in their pocket, like this iPhone or something, probably something even better, which of course has an impact on how we live our lives. And the network not only consists of people, it will also consist of machines, what we talk about now as the Internet of Things, and they will constantly be exchanging data. Some of these data you will be aware of, some of it you will not be aware of because you're not really producing it yourself, but it's data being produced by machines that you're connected to, working somehow or somewhere on the Internet without you knowing, and making services, doing services, which will make your world appear like magic in a Harry Potter movie. And we will have devices like this. This is the blue Apple smartwatch, whenever it arrives. I'm not sure if they just put on it. But the important thing to ask when you talk about all these products and all these new ideas and computing power, moving upwards in an exponential curve is what kind of problem do you actually solve with this technology? I mean, do we really need all these technologies, or does someone else think we need them? And it's actually, when I talk about this event horizon, which Ray Kurzweil has described being very difficult to grasp, what will be the next step, what will happen next, how will this product or this thinking change the world in 5, 15, 20 years' time. We have to think about this exponential curve. If you look at something like this, does anyone know what this is?
First computer mouse.
Exactly, it's the first computer mouse. It's at the Computer History Museum in Silicon Valley, not here. It was invented by this guy, Professor Evelyn, back in the 60s. It is something else which is actually more important than just inventing the mouse. He invented the hyperlink, he invented copy and paste, and he actually also connected the whole thing into a network, which is the early days of the Internet. It took 17 years before Apple actually turned this into a product called use. But sort of the general idea, the general acceptance and use of the internet came much later, meaning that the hyperlink and so on didn't really fit in anywhere because nobody really knew what to use it for. This is not very good because you can't really see the curve. Anyway, the curve starts down here. It's all flat. So somewhere down here at this point, right? Yeah, well, maybe we should just run it like this. We'll just try. Yeah. Technology. You know, they have a saying at the Singularity University, you know, AI, that's artificial intelligence. So what they're saying is AI is easy, AV is difficult. So that's the Singularity University joke. Anyway, What you see here is, I mean, if you look back at Dr. Slingerbar and you look at the hyperlink and so on, and what we actually did, turning the what was actually a calculating machine into a knowledge machine. At this point, we didn't really know what to use the hyperlink and all the other stuff in there for. But at a certain point, which is called unique, we actually reach a point where we can actually see, well, now we know what to use it for. I mean, this would probably be the early days of the internet or the World Wide Web back in like 22 years ago when I started my radio program. And you could sort of see, hey, what will this develop into? And if you design a product, I mean, it would be really great if you were down there to sort of see what can I develop this into. But it's really, really difficult to see what's happening down there because the doubling is the numbers are so small. So you can't really see what's coming next. You will only find out when you reach the need. So what is actually happening when we have something like the first iPhone, which Steve Jobs is presenting here. A lot of people will say, well, it's just a toy. I mean, the antenna is not really good. It doesn't have flash, which was a big critique of the first iPhone. It can't do video, and it doesn't go very long on battery, so it's really not a very good product. So it's just a toy, and now there was like, well, how big is the market share? Well, it's zero. Well, we don't take it seriously. Why would we do that? But the funny thing is, there's a guy called Clayton Christensen from the Harvard Business School, and he made this slightly complicated model. But if you look at the blue line, that's the way incumbents sort of develop products. And down here you have the newcomers. The green line, disruptive innovations, which will change the world. The people who have sort of a bit down the exponential curve, but they know that a bit further up the exponential curve, this technology will have a breakthrough. So when does it have a breakthrough? I mean, when does the price, the technology, and the sort of what the consumer really wants, when does this all come together? And surprisingly, it comes together earlier than you would expect. It actually comes together creating a product which is probably slightly worse or not as good as the product you would have on the market before. But it's good enough for the customer to pay the price to actually get this product. I mean, Euan talked about the ecosystem that Apple created around the iPhone, which is probably the reason why it won, because the iPhone in itself wasn't really that good at the starting point. But if you create a new product, I mean, you don't have to create a perfect product, but just a product which is good enough that people will actually buy it and use it. And that's why you see companies like Uber, Airbnb really kicking off, because they started very, very limited products and then they build it up, finding out what will the consumer actually pay for, what do they need, and can we provide it in a very fundamental way. You also have something like Kickstarter, which means that you don't really have to go to your boss to pay for money, or you don't have to go to a venture capital. And I will come back to Google Car later. Funny thing is, it took Hilton 93 years to build an inventory over 600,000 hotel rooms, and Airbnb got there in just 4 years. Same time span that a pupil would spend at the Cushing Academy. That's worth thinking about. BlaBlaCar, you know BlaBlaCar? It's a French ride-sharing company. They actually transport more people than this train, which is going from, I believe, Paris, Brussels to London, high-speed train. So BlaBlaCar actually transports more people than they do now. So what is happening here? If you think about the exponential curve we have, the thing is, we mostly think linear. That's the way we sort of can interpret the world. I mean, it's like everything changes a little bit every day. And we don't really see when something is stopping until it's reached a certain point. And being in this area is actually the most interesting place to be, because that's where you can actually see this disrupting happening. So if you want to develop a product, I mean, this is the place to be. I mean, if you think like this, you probably won't make it. You have to think like this, and you have to act quickly. So can you actually plan for you plan a disruption, what do you think?
Yes.
You think so? But would it be a disruption if you could plan it?
Yes.
It would be, well, how? I mean, you will plan something that you don't know what is.
No, you can plan on changing a market, disrupting a market. You might not know what the outcome is, but
That's maybe planning for a disruption. That's something different. But because sometimes we confuse it, because if you can plan it and you can produce it, it's not really, okay, if you produce it, it could be a disruption, but it's really hard to say what it is. But you could plan for a disruption. A way to do that, Google is doing it by creating what they call moonshots, which is of course inspired by the talk that President Kennedy gave back in the 60s, the start of the 60s, and they said, well, we're going to want to go to the moon before the century is over, and they did it. And how do they do it? They have a huge problem, they have a radical solution, and they have some breakthrough technology. And that's actually the way that the Solve for X or Project X, it's actually an internal company sort of at Google, and that's the way they work. I mean, don't concentrate on all the other stuff too much, but they have made the Google Glass, they have made the self-driving car, and there it is, and the Google Lens, which is now, I'm not sure what the technology is called by Novartis, but they're actually working together with Novartis on creating this contact lens, which actually, it measures the amount of glucose in your tears. And it also has, as you can see, a sensor, it has a chip and an antenna built in. So it's really a smart product, I would call it. And it's developed at the Software X at Google. So how do these companies think? The international ambassador from the Singularity University is a guy called Sven. He spent 4 years thinking about, well, why do we see companies like Uber and Airbnb, and how did Google and Facebook become what they are today? And he started sort of analyzing these companies and doing a lot of questionnaires and interviews, and he wrote this book, Exponential Organizations. What he found out, among other things, is that these companies always have a massive transformative purpose. These are some examples. Just read through them. One thing they have in common is that they're not very modest. They really want to change the world. And what you should think about here is that some of these companies, I mean, they sit in the garage, two guys, and they come up with this massive transformative purpose. I mean, it's like, I'm in the garage, I want to change the world entirely. And how do you do that? You can actually do it through technology today, of course. Because of Moore's law, we now have very powerful technology in our hands, and we could maybe meet up at a cafe or in a garage and start changing the world through laptops or whatever we have. Celine has made this division. I mean, if you look at the ideas, it's sort of what you can do in the garage. I mean, you will have interfaces, a bit like a Facebook, where you can actually handle a lot of people and a lot of different tasks. Same thing with dashboards. Experimentation is very, very important, that you will prototype and do stuff and change it and do it again and change it. You have a very large degree of autonomy. For instance, if you fund your company through Kickstarter, and you don't really have to you don't have to have meetings with your boss or the VC all the time. You just someone's, and maybe you don't really have an office and things you can move about. And of course, social is very, very important, that you have community or crowd, which is also a very large part of doing, for instance, a Kickstarter campaign. You're always in contact with people who want support. But what happens if you want to grow and you want to leave the garage, you want to do a real proper company? I mean, you have to go to the other side of this slide. You might want to hire some old people, but you don't really want to hire them. if you don't need them. So you start with demand, you still need your community and your crowd to sort of grow it, to spread the message, to spread the idea of the product happening. So you need a lot of computing, a lot of algorithms to sort of take care of stuff that we usually have people to take care of, to maybe put machines into work. I mean, if you have in the future maybe some kind of artificial intelligence, you will see that there's a lot of algorithms involving what Google is doing, what Facebook is doing, and so on. Your assets. I mean, you don't have to buy a basement full of service anymore. You can rent it as you go. For instance, with Amazon. And of course, you have to have a basement, which is also obvious. I'm not sure why you put it there. But anyway, you have to really live this through. But that's his idea of how these exponential organizations they actually develop, so the characteristics that they all share. You also have to reduce the friction. I mean, if you're a big company and you want to do this, you have to reduce the friction within the company. At Amazon, which used to be sort of a garage thing, but now they're really huge, they have what they would call the institutional yes. So if someone comes up to his boss and says, I have this brilliant idea, the boss doesn't really want it, he has to file a report of 2 pages on why he said no, and he has to publish it on their internet. Which means that they are sort of reducing the no's and trying to get more yes to products. And it apparently works. There's a guy here called John Hagel. He works with something called the White Center of the Edge, and Center of the Edge is sort of really, I mean, it's, what do you say, the loose yeah, it's contradicted. Thank you. Sorry for my broken English. But what he's saying is, if you really want innovation in a big company, you have to go to the edge of the company to see what's going on out there. But the problem is, if you identify someone out there who's really doing something important, has a new idea which will really change the direction of the company will usually act with its immune system like this is a virus threatening the company, because it will threaten the ways that we usually do stuff here. So they will see it as a threat to the immune system, and they will kill the new idea. And believe me, I've been working with big companies. Denmark's Radio is one of those, and it's really the way it works. So what you have to do is you have to get one person, as John Hayes puts it, from the leadership to sort of be patron of this idea, but only one person. And then you will have to develop this sort of in secrecy at the edge of the company. And then you can, if it works, you will slowly drag it into the center of the company and sort of let it develop. How can you actually do that? I met some people at IBM in Cambridge in Boston. Who were working on what they call crowdfunding behind the firewall. So they have this crowdfunding project. Everyone who works at IBM gets in certain departments, I should say, it's not all IBM. They get $100, which they can invest in proposals for technology and new stuff that other people at IBM would like to have. So you post your project on the internal crowdfunding side, and all your peers, all your colleagues can invest in it. And everyone who's part of the leadership in any way cannot invest in it. So it's only your peers, your colleagues who can invest in this. And it works like crowdfunding does in the real world, so to speak. When if your project is funded, well, you can go and do it, and if it's not, the money goes back, and then you can reinvest this way. What happened here? They ran 4 times in 4 different departments. They had very high participation rates. People came together across departments, across nations actually, because IBM is international. And they discovered colleagues and people who would actually collaborate with from all the departments in other parts of the world. And they actually also they learned that they could actually invest in something that they wouldn't gain anything from, but they would do some good for a colleague they didn't even know, or someone who was maybe sitting at in an office on the other side. And you can create products or services that are just about good enough that you can actually maybe give them away or sell them, or at least test them with the audience, with customers, because it has become so cheap to develop these software. To some extent, you can also develop hardware when you do 3D printing and other stuff. I mean, and the IdemoLab you saw here, I mean, would be perfect for also trying trying off an idea. And some of the products that you have seen on the Kickstarter they're not really finished products, and sometimes when you see them, they're really in beta, and you get sort of disappointment because it's not until the next generation that it will really work, which is of course a problem. But they have this cycle, meaning that you build something, you measure it, you analyze it, you learn something, then you build the hypothesis, and then you build it again. So this is this prototyping circle, which has become faster and cheaper because you have this stronger technology now, according to small goal. And that's actually the idea of the startup, which we see sort of penetrating Silicon Valley these days. And there's not a saying there's no tendency in launching too early, but there's a tendency for launching too late. Meaning, as a customer, you might get some products that you're not completely satisfied with. Thinking about the first iPhone compared to the iPhone 6, but it will be there and it will might cost you some money. I'd like to get back to Singularity University because I'm involved there. I was there as a pupil. I was there as a reporter when I had visited James Tracy at the Cushing Academy back in 2009. I went to the Singularity University a couple months later to see what are they actually doing here, what is this all about. And I came back and did a full week course for the ISRO. They're working on what they call grand challenges, global grand challenges. I mean, a way to impact the world, change the world for the better through technology. And the way they do this, they have these 1 week training courses for people who are able to pay for it. That's the one. And then don't have time to spend more time over there. So it's usually executives, or I have the opportunity to be there as well. And then they have these 10-week programs in the summertime. And they're really aimed at entrepreneurs. But not all entrepreneurs, maybe from Africa, India, or Latin America. Maybe you can't really come up with $30,000. So what they did, they made these local impact competitions, which are local competitions run by local people with a local sponsor. And we were a group of people in Denmark who have been there, so we thought, we want to do one of these. First, I should actually tell you about what they consider the global grand challenges over there. So you see they're really big problems. And the thing is, what they want people to do is to create startups like exponential organizations that can grow very fast and solve some of the problems within these fields. And I got some examples of some of the companies that have come out of Singularity University. Made in Space came out of the 10-week program in 2010. This is a 3D printer meant for space. So right now it's actually, they have this printer at the International Space Station, and it's printing parts for repairing stuff up there, because the very expensive thing is actually you need a rocket to take stuff there, so you can actually first take the 3D printer and then only the sort of plastic to make the spare parts up there. You don't need to put the spare part on a rocket, and it takes a lot of fuel and takes a lot of time to get it there. Now they can actually print stuff up there. So that's the sort of the first prototype of doing this in space. So you don't have to send a lot of stuff up there. Another company which is not directly spun out of Singularity University, but it's associated with Singularity University, is something called Genome Compiler, which is basically a cut and paste tool for genetic material. So what you're cutting off there, splicing and putting together in new ways is actually DNA, which is rather mind-blowing and actually create new organisms in your computer, which will in due time, of course, be very important when you're doing drugs and stuff like that, medicine. Another company which is directly spun out of a program at Singularity University, I believe in 2012, summer of 2012, is something called Cambridge Genomics. The problem is when you have created an organism inside your computer, designed it and so on, how do you actually put it into the real world? Well, you mail the code to Cambridge Genomics and they will print it for you. So you will receive this genetic material in this small chip, and you can actually go into the web lab and work with it. This is the guy who founded Cambridge Genomics, Austin Hines. Very clever young gentleman.